Hi everyone, my name is Pradyumn Kejriwal, and today we will discuss the 21st problem from the CP sheet by TLE Eliminators under the rating of 1400. So let's begin. So I have my sheet here and I can open this problem. So it is called Johnny and Another Rating Drop. The last contest held on Johnny's favorite CP website has been received positively. However, Johnny's rating has dropped again. He thinks that the presented tasks are lovely but don't show the truth about competitor skills. The boy is now looking at the ratings of consecutive participants written in a binary system. He thinks that the more such ratings differ, the more unfair is that such people are next to each other. He defines the difference between two numbers as the number of bit positions where one number has 0 and the another one has 1. We assume that the numbers are paired with leading zeros to the same length. For example, the difference of 5, which is 101, and 14, which is 1110, equals to 3 because 0101 and 1110 differ in 3 positions. Johnny defines the unfairness of the contest as the sum of such differences counted for neighboring participants. Johnny has just sent you the rating sequence and wants you to find the unfairness of the competition. You have noticed that you have got a sequence of consecutive integers from 0 to n. That's strange, but the boy stubbornly says that everything is right. So help him and find the desired unfairness for received numbers. So this problem statement is very complicated. It doesn't need to be very complicated. So I'll just explain what it is actually saying. Okay. So what they are saying is that they have given us a number n, a positive integer n, and we have a sequence of numbers from 0 to n, that is 0, 1, 2, 3 and so on up to n. And for every pair like of consecutive numbers, let's say for 0 and 1, for 1 and 2, for 2 and 3 and so on, and for n-1 and n, we have to find out, like for every pair we have to find out their difference. I mean not the difference, like here they have defined the difference in a different way, like the difference between 4 and 5, let's say, like 4 is what, 100 and 5 is 101. So their difference is 1 because they differ in 1 bit. Like these two bits are same but this bit is different, right? And for example, let's say we have 8 and 4. So 8 is 1000 and 4 is 0100. So here their difference is 2 because they differ in 2 bits, right? So this 2 is there. Okay, now what they are telling us is that we have to find out the difference between each consecutive element in this list and find the sum of that, like just add all of them. So for example, they have given a test case in which n is equal to 5. So for n equal to 5 the answer is 8. And why is that so? Because, okay, let's see, we have 0, 1, 2, 3, 4 and 5, and let's just calculate the difference. So between 0 and 1, 0 is 0 and 1 is 1 in binary, so their difference is 1 because they differ in this bit. So this is 1. Then between 1 and 2, 1 and 2, so 1 is 0, 1 and 2 is 1, 0, so they differ in 2 bits. Then 2 and 3, they differ 1, 0 and 1, 1, so in 1 bit. Then 3 and 4, we have 0, 1, 1 and 1, 0, 0, so 3 bits. And between 4 and 5, they differ in 1 bit, 1, 0, 0 and 1, 0, 1, so 1 bit. So totally 1 plus 2 plus 1 plus 3 plus 1, it is 8. So therefore the answer for n equals to 5 is 8. Alright, and similarly you can try to find out the answers for all the test cases except for this one. Like don't try doing it for this one because you will be you will take too much time. Okay, so yeah, this was the problem, and the constraints on n are up to 10 to the power 18. Alright, so it is pretty huge, so you can't even do O of n solutions because you can only do up to 10 to the power 8 operations per second. So O of n won't work because n can go up to 10 to the power 18. And also O of root n will also not work. O of root n will not work. But O of log n may work. O of log n might pass. And of course O of 1 might pass. Alright. So you just try to do it in one of these complexities. Or log square n also works. And so on. Like, you get the point. So just try this problem now that I have explained this. And if you want a solution, then just unpause the video. Alright. So I'm assuming that you have tried it by yourself, and I'll just explain it to you now. Alright. So guys, notice one thing, that what we are actually doing here is that we are taking the consecutive numbers and looking at the difference. So like, for example, if we have n equal to 3, let's say, then we will write the numbers till 3, like 0 0 0 1 1 0 and 1 1, and we will take their difference. So like, this difference is 1, this difference is 2, and this is 1, and we will just add them and find the answer. So it might be useful, like, since we are dealing binary here, this binary form we are dealing with, so it might be useful if our n is a perfect power of 2. Like, let's say if n is a perfect power of 2, let's say 2 to the power k, then what is the answer? Let's try to find it out. Okay, so to find it out, I have an observation method. Like, I will just find that out by observation. Okay, so for that, let's assume that the value of k is something. So let's say for k equal to 3, I want to find out. That means for n equal to 2 to the power 3, I want to find out the answer. So how do I find out? Let's try to write all the numbers. Okay, so we have 0 0 0 0, 0 0 0 1, 0 0 1 0, 0 0 1 1, 0 1 0 0, 0 1 0 1, and 0 1 1 0, 0 1 1 1, and also 1 0 0 0. So like, I just wrote all the numbers from 0 up till 2 to the power 3, right? Now I want to find the answer, that is the total difference. The total difference. Okay, now there is one thing that I can do here, is I can just calculate this bit by bit. Like, see, what I want to find out is that how many bits are different. Like, in these two, the difference is the number of bits which are different. So it is 2 in this case. Then for these two numbers, it is only 1. Like, only this bit is different, so it is 1. Then for these two numbers, it is 1 and 0. So we have 2 now. And also this bit, so we have 3 in fact. So I am just counting the number of bits for each pair. Like, for each adjacent pair, I am just counting the number of bits which are different. So what if I count it bit by bit? Like, what if I just count for this bit? Like, see, these two are different. So 1, then 2, then 3, then 4, then 5, 6, 7, and 8. So for this bit, I have 8 consecutive pairs which are different. So essentially, this bit will contribute 8 to the answer. Alright, so this unit digit will contribute 8 to the answer. Right, then what about this 2 to the power 1 digit? So this changes in how many pairs? So here it changes, then here it changes, then here it changes, and here it changes. So it changes at 4 places. So it will contribute 4 to the answer. Then what about this bit? So this bit changes at this point and at this point. So it will contribute 2 to the power, like, it will contribute 2 to the answer. Right, this was 4, this was 2, this was 8. And similarly, this last bit, it changed only at the last position. Like, at this position it changed. So it will contribute 1 to our answer. So basically our answer is just 8 plus 4 plus 2 plus 1. So like, I just found that out by calculating the bitwise contribution for each bit. Alright, and that's pretty simple. So like, why am I getting like this? Like, one thing to notice is, why am I getting this pattern, like 8 4 2 and 1? So to digest that fact, I have one more thing to tell you. Like, see, if you just have a look at the unit digit, like just forget about everything else. Okay, wait a minute. So if you just have a look at the unit digit, okay, like just look at this column, you can see that this unit digit changes every number. Like after every number it changes. So 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0. So it is changing after every number. So since we have like 9 numbers, right, from 0 to 8, from 0 to 8 I have 9 numbers. So I have 8 consecutive pairs, and in each pair this unit digit is changing. So that's why it is contributing 8 to my answer. And what about the tens digit? Like, I mean, the 2 to the power 1 digit. So that is changing every 2 numbers. Like it is 0 0, then 1 1, 0 0, then 1 1, right? So every 2 digits, I mean every 2 numbers, it is changing. And since we have n pairs of numbers, like it will be n by 2. It will contribute n by 2. Like what I am saying is, since this digit is changing every 2 numbers, and we have n numbers, like we have n changes or n transitions like this, 1 2 3 up to n, right? So that's why it will contribute n by 2, since it is changing every 2 transitions. And similarly this 2 to the power 2 bit is changing every 4 transitions, so it will contribute n by 4 to the answer. So in general, if I want to find out my answer, I can just say that, like if I have n which is a power of 2, then the unit digit will contribute n to the answer, then 2 to the power 1's digit will contribute n by 2 to the answer, then n by 4, and so on up to like 1 basically, right? If I just put this value of 2 to the power k, or like basically we can solve this GP, right? This is a GP, and its answer would give you 2n minus 1. Like just apply the formula for this GP and the answer would be 2n minus 1. Okay, so you can just find out the answer for a power of 2. So like the answer for n is 2n minus 1 if n is a power of 2. Okay, but how do I find out the answer for those numbers who are not powers of 2? How do I find it out? We can do that by using our brain. Like we can do that by just observing some more things. All right, so let's say I have a number which is not a power of 2. So let's say I have 12. Okay, my n is equal to 12. Or let's just take a smaller number so that it is easier. So n equal to 6. Okay, so let's draw this again. So I'll do 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 and 1 1 0. This is 6, right? Now what I propose to you is, okay, since we want to find out the sum of pairs like this, so this pair difference plus this pair difference plus this pair difference plus this pair plus this pair plus this pair. Okay, so what I propose to you is just divide this into 2 parts. Okay, like just have this one part, okay, and this another part. So basically just find out the answer for the range 0 comma 4, right, and also the answer for the range 4 comma 6, and that will give you your answer for the range 0 comma 6, right? As you can see here, this is 0 comma 4 ka answer, this is 4 comma 6 ka answer, and it will give you the answer for 0 comma 6, and that's what we want. But how do we find out the answer for 4 comma 6? See, we already know the answer to 0 comma 4 because this is just a power of 2, right? And we have calculated the answer for that, like it is 2n minus 1. So this answer is just 7. All right, but how do we find out the answer for 4 comma 6? For that we can simply do like we can simply observe the thing here. Just see that here you have this 0 0 0 1 and 1 0, right? And like let's just say that you want to find out the answer. So if you just ignore this one bit, like see, we want to find out the number of changes, right? So this one bit is not really changing, right? It is not really changing. So if you just ignore that, okay, if you just ignore that, like then answer won't change. If you just find out the answer for these bits, then it is the same, right? So like just look at these numbers in isolation. Then what do you see? It is just 0 0 0 1 and 1 0. So basically it is the answer for 2, right? Like we have 0 0 0 1 and 1 0. So this is the range 0 comma 2, and we already know how to find the answer for that. Okay, so I just proved that the answer for this range, that is 4 comma 6, is the same as the answer for 0 comma 2. Why? Because this bit right here is not even changing, so we can just ignore that part because it will not contribute to the answer, and the remaining bits are just the numbers from 0 to 2, right? So we can kind of break this number, like we just broke this 6 into 4 and 2. Like see here, what is the final answer? Our final answer is the answer for 0 and 4 plus the answer for 0 and 2, and that's the answer for 0 and 6, right? And in general also we can do this. Like here this 6 was basically 4 plus 2, right? It was 4 plus 2. If I write it in terms of powers of 2, then it is 4 plus 2, and that's why we could just do the answer for 0 comma 4 plus the answer for 0 comma 2. Now if I like show you one more example, let's say for n equals to 7. Okay, I'll just again draw the table which is formed. So 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0. Okay, I just messed up, I think, or I didn't. Okay, I have to start from 0 0 0. Yeah, so to find the answer to this, what I'm proposing is that okay, 7 is equal to 4 plus 2 plus 1, right? So just break that, like break it like that. So like you want to find the answer to this, right? So just break this into different parts. So this is the first part, from 0 to 4. Then from 4 to 6 is one part, and the last part, it will be from 6 to 7. All right. And if you see that okay, the answer to this one is just it is just like 0 to 4 range, right? 0 to 4. So we can just find the answer to that. Then if you want to find the answer for this, then if you just ignore this one, then this part is just the answer to 2, 0 comma 2. And if you want to find the answer for this, then if you just ignore these two bits, then this is just the answer for 1, so 0 comma 1 range. So just find the answer to all of these parts and just add them up. So as you can see that if we have 7 and it is 4 plus 2 plus 1, then its answer is just the answer for 4 plus the answer for 2 plus the answer for 1, right? And in general, if I have n and I write it in the binary format, that is, let's say 2 to the power b1 plus 2 to the power b2 plus up to 2 to the power bk, then the answer is ans of 2 to the power b1 plus ans of 2 to the power b2 up to 2 to the power bk, like ans of 2 to the power bk. And you can even simplify this even more, because you know what is the answer to the powers of 2? It is just 2n minus 1. Like if this is called n, then its answer is 2n minus 1. So if I have 2 to the power b1, then what is the answer? The answer is 2 to the 2 into 2 to the power b1 minus 1, or in other words 2 to the power b1 plus 1 minus 1. So this is this first term. Then the second term is 2 to the power b2 plus 1 minus 1, and until the last term, and then you can just take out the 2 common, and it will become 2 to the power b1 plus 2 to the power b2 up to 2 to the power bk, right? And these minus ones will accumulate, so minus something will happen, like basically the number of set bits, or basically the number of terms in this series, right? The number of terms in this series, and that is just the number of 1 bits in n, so the number of set bits, right? And this is just like, you can observe that this was just n, right? I had written the n in this binary format, so this is just n. So the answer is 2n minus the number of set bits. Okay, this is the final answer. So if you have an n, then you can just print this final answer, and it is pretty simple. So I'll just explain one more time if you didn't get. What I was doing here is that I saw that if we can write this n in the terms of like sum of binary numbers, then I can find out the answer to all of them individually and then add them up, and that will give me the answer for the entire n. So if I write n in binary, like if I can write n, let's say as 1101, let's say n is 1101 in binary. Okay, so what does this mean? This means that we have 2 to the power 3 plus 2 to the power 2 plus 2 to the power 0, like because the 2 to the power 1's bit is not there. So I have written n like this, and then I can just find out the answer for 2 to the power 3, 2 to the power 2 and 2 to the power 0, right? And that will give me 2 into n minus whatever terms there are, which is 3. Like if you just apply the formula, like if you want the answer for n, then that is equal to the answer for 2 to the power 3 plus answer for 2 to the power 2 plus the answer for 2 to the power 0, and this is basically equal to, like, the answer for 2 to the power 3 is what? It is 2 into 2 to the power 3 minus 1. Then this is equal to 2 into 2 to the power 2 minus 1 plus this is equal to 2 into 2 to the power 0 minus 1. And if I combine these 3 terms right here, like if I just take out the 2 as common, then I will be left with 2 to the power 3 plus 2 to the power 2 plus 2 to the power 0, and this is just n, right? And then minus the number of terms, minus the number of terms. And what's the number of terms? As you can see, it is just the number of set bits in this, like these 3 bits are 1, so we have 3 corresponding terms to that. So 2n minus the number of set bits, right? And that's the formula for our answer. Alright, this is the answer. So this was just like mathematical question, and the code is pretty simple, obviously. Like in the main function I have the fast IO and the test cases I'll run, and in the solve function I have this long n. I am taking the input, and it is long because the input can go up to 10 to the power 18, and then finally I am printing 2 into n minus number of set bits in n. So this function right here gives the number of set bits in n, and it works in O of 1 time complexity. Like it uses some CPU instructions to just find out the number of set bits in O of 1 time. So 2n minus number of bits in n will just print that in O of 1, and we don't use any extra space also, so the space is also O of 1, time is also O of 1, right? So I hope you understood this solution, and thanks for watching. I'll see you guys later.